The James Webb Space Telescope, JWST, has once again made headlines with a groundbreaking discovery that could rewrite our understanding of the early universe. This time, it has identified a galaxy so ancient and unusual that it's forcing scientists to reconsider long-held assumptions. To appreciate the significance of this find, we need to take a step back, not all the way to the dawn of time, but to the year 2022. Before 2022, the farthest known galaxy ever observed was GNZ11, a discovery made by the Hubble Space Telescope. This finding marked a major milestone in astronomy. Hubble, equipped with a 2.4-meter mirror and powerful optics, had taken us further into the cosmos than ever before. However, there were limits to how deep into space, and back in time, it could see. That changed dramatically with the launch of the James Webb Space Telescope, boasting a much larger 6.5-meter mirror and specially designed to detect infrared light, the exact type of stretched, ancient light emitted by early galaxies. JWST didn't just build on Hubble's legacy, it shattered its records. In one of JWST's early observational campaigns, it discovered a galaxy named JD's GS Z13-0, which at the time held the record for the most distant confirmed galaxy. It had a redshift value of 13.2, meaning its light had traveled for over 13 billion years. Soon after, an even more distant galaxy was identified, MOM Z14, with a redshift of 1444. Redshift, in simple terms, measures how much light from a galaxy has been stretched due to the expansion of the universe. The higher the redshift, the older the galaxy. The discovery of MOM Z14 astonished astronomers, not just because of its distance, but also due to its characteristics. Despite being relatively small, measuring only about 500 light-years across, compared to our Milky Way's span of over 100,000 light-years, MOM Z14 is exceptionally bright. Galaxies from this early epoch are generally expected to be faint and difficult to detect, yet this one is bursting with star formation. It appears to be a vigorous stellar nursery, rapidly producing new stars in the universe's infancy. Even more puzzling is what MOM Z14 doesn't have. There's no evidence of a supermassive black hole at its center. Typically, galaxies that form stars at such a high rate also host central black holes, which are believed to regulate star formation and play key roles in galaxy evolution. The absence of a black hole in MOM Z14 defies expectations and deepens the mystery. Additional observations using JWST's spectrograph revealed another surprise. MOM Z14's light is unusually rich in nitrogen. This chemical signature closely resembles what is seen in some of the oldest globular clusters orbiting the Milky Way, implying that MOM Z14 is forming stars in an incredibly dense environment. This is unexpected because early galaxies were thought to be chemically simple, composed mostly of hydrogen and helium. The presence of nitrogen indicates that several generations of stars must have already formed and died before MOM Z14, suggesting that galaxy evolution began much earlier than previously believed. This raises a profound question. How many other galaxies like MOM Z14 might exist? Prior to JWST, it was assumed that galaxies from such an early time in the universe would be extremely rare. But now, astronomers are finding more of these ancient bright galaxies, often referred to as little red dots, than they ever anticipated. MOM Z14 currently holds the record for the most distant confirmed galaxy, but it may not retain that title for long. What makes this particularly exciting is the implication that the early universe was far more active and complex than our current models account for. MOM Z14 is not just a distant galaxy, it's a challenge to the foundation of cosmological theory. Existing models suggest that early galaxies should be rare, slow to grow, and chemically simple. MOMZ14 is none of these. It formed rapidly, shines brightly, and shows evidence of chemical complexity. This doesn't necessarily mean our models are wrong, but it does mean they're incomplete. MOMZ14 is a compelling clue that the early universe may have been a bustling, dynamic place full of rapid development. This discovery is only the beginning. Later this decade, the Nancy Grace Roman Space Telescope will join JWST in exploring the early universe. Unlike JWST, which offers deep but narrow views, Roman will survey much larger areas of the sky in incredible detail. Together, these telescopes could uncover hundreds or even thousands of galaxies like MOMZ14, each one a time capsule from a formative era of the cosmos that we are only just beginning to understand. Yet, MOMZ14 stands as a monumental discovery for now, a flicker of light from a time when the universe was still in its infancy. And the more we analyze JWST's data, the more the cosmos seems to defy our expectations. Some scientists are interpreting these findings to propose something even more radical, that our entire universe might exist within a black hole. Recent research has uncovered a peculiar pattern. Most galaxies seem to rotate in the same direction. By examining the curvature of their spiral arms, scientists have observed a surprising lack of randomness. In a truly isotropic universe, we would expect galaxy spin directions to be evenly distributed. This unexpected alignment contradicts existing cosmological models and hints that our universe might be the interior of a black hole within a larger parent universe. This idea falls under a theory called black hole cosmology, or Schwarzschild cosmology. According to this view, the observable universe could be what exists inside the event horizon of a massive black hole. When matter collapses under its own gravity to form a black hole, it creates an event horizon, a boundary beyond which nothing can escape. While the outside observer sees only darkness beyond this boundary, the internal structure remains mysterious. The theory proposes that, instead of ending in a singularity, the collapse could trigger a big bounce, in which the core of the black hole rebounds and expands, giving rise to a new universe. This reimagining of cosmic birth could help explain several long-standing mysteries. For instance, it might clarify why the fundamental constants of nature appear fine-tuned for life. If each black hole births a new universe, then only those with stable physical laws would persist and potentially generate life, effectively creating a form of cosmic, natural selection. It could also account for the immense entropy of black holes, which may correspond to the vast information content of entire universes within them. Another concept that ties into this theory involves torsion, a feature in some extensions of general relativity, such as Einstein-Cartan theory. Torsion takes into account the intrinsic spin of particles and its influence on spacetime. Some models suggest that torsion might produce a repulsive force at extremely high densities, preventing the formation of singularities. Instead of collapsing infinitely, a black hole might undergo a rebound, a big bounce, triggering the expansion of a new universe from within. If this is the case, then our own Big Bang might not have been an explosion from nothing, but rather the aftermath of such a bounce. The rapid expansion we observe today could be the result of matter rebounding from the core of a black hole in a parent universe. This self-replicating process could mean that every black hole in our universe has the potential to spawn its own universe. Further studies have also found that the universe might possess a preferred axis. The large-scale distribution and movement of galaxies suggest a non-random alignment, challenging the widely accepted cosmological principle that the universe is uniform and isotropic on the largest scales. If confirmed, this anisotropy could point to new physics, possibly connected to how our universe was formed or how fundamental forces behave across cosmic distances. Additionally, the discovery of massive, mature galaxies so soon after the Big Bang questions the current timeline of galaxy formation. While the idea that our universe exists within a black hole is provocative, it's also possible that more conventional explanations, like errors in earlier measurements, particularly of the Milky Way's rotation speed, could account for some anomalies. Regardless, one thing is clear. The universe is far stranger and more complex than we ever imagined. The surprising findings on galactic rotations and ancient galaxies will undoubtedly lead scientists to reassess several aspects of current cosmological theory. What do you think about these discoveries? Share your thoughts in the comments. And don't forget to subscribe for more insights into the mysteries of the cosmos.